In this video, we are going to discuss the question number 4 of section 2.2 in the geometry of numbers by C.D. Olds and the co-authors. Let's come to the problem. The problem is displayed here. The number of lattice paths from the origin 0, 0, 2, the lattice point on the line x plus 2y equal to n is equal to the nth term of the Fibonacci sequence 1, 2, 3, etc. A lattice path is like a route of a taxi allowed to travel from the origin to north, either to north or to east along the lattice. This means in particular that only lattice points with the non-negative integer coordinates are accessible. Show by drawing that if n equal to 7, the number of paths from the origin to the lattice point is 7, 7, 0, 5, 1, 3, 2 and 1, 4 is equal to 21. We need to know to find the answer to this question. We need to know what is meant by a lattice path. A lattice path actually is a path connecting lattice points in the fundamental lattice. For getting more information about lattice path, I shall direct you to the relevant page in Wikipedia. You can see it here. Based on using this page, you can explore. You can understand what's a lattice path. You can see in this figure a simple lattice path starting from the point V0. It is originating at V0 and extending or ending at V5. This path links V0 to V1, V1 to V2, V2 to V3, V3 to V4 and V4 to V5. In a similar way, many paths are possible. You can see, for example, if we consider this lattice point instead of V1, you can join it to that point and you can give a suitable name to that point, and then you can directly draw it to link it to V2, then come back tracing back the same path. You can come back to the point V5. Now it is clear what is meant by a lattice point. By a lattice path. But here some additional conditions are also included. Some conditions are also included in the question. So for that, for explaining it further, let's come back to the question. Here, not all paths are allowed. In this way, we can see that many paths are possible. Not all paths are allowed. What kind of paths are lattice paths are allowed? Here, only those paths are allowed which is like a taxi is allowed to travel straight to north, or either in the north direction or in the east direction, which proceeds either in the north direction or the east direction. Okay, then following this condition, you can see referring that figure, you can see, and this is not a path which is allowed. Following that condition, strictly obeying that condition, you cannot allow this path. It's because here in this path the taxi moves. It is not moving upwards. It is moving in the northeast direction. In the northeast direction it is moving. Along this path it is moving. But this is allowed. This portion is allowed, but this portion is not allowed. see this portion from V2, the portion from V2 to V4 is not allowed. But this is allowed. It can move from V4 to V5. So as a whole, you cannot accept this as a path specified in the question. So now it is clear what kind of paths are possible, what kind of paths can be allowed. Now you can say, for example, suppose this is the origin. So not only that, you have to start from the origin and you have to end at either of the 4 points given in the question. In the question, you can see four points are given. Exactly 4 points are given, and up to that point you can take the paths. You can take the paths up to that point. But not only that, you can see the lattice points are present on number of lattice paths from the origin to the lattice points on the line x equal to 2x x equal to x plus or to the line x plus 2y equal to n is equal to the nth term of the Fibonacci sequence is defined by. Okay, this is the lattice path. Okay, yes. So you have, in this way, you have to find all the lattice paths which are strictly following the rule given here, and then you can mark those paths. You can mark those paths in the fundamental lattice, and then you can count its number. This way you can see that the total number equal to, you can verify that the total number of such paths is equal to 21. That's all.